Hi everyone, I'm on video and we start the lecture. Do you have any questions from the quizzes or the last lecture? Good. Yeah, every year I get some questions about the linear algebra, and the linear algebra is prerequisite for the course. And I understand that you may forget some materials, but if you forget many of the materials, I recommend you to review some textbook. Yeah. The eigenvalues, eigenvectors, those are not really crucial to finish this course. So you don't really have to worry too much about eigenvalues and eigenvectors. But if you have questions, you can just ask me during office hours. I got some questions. Yeah. Hi. Thank you for the message. And yeah, so last time we are doing we have finished the slides up to 50, 57. So we start with 58 and others. Yeah, today's materials are, first apply functions. So that is convenient to summarize data. And so I discuss maybe 4 functions about summarizing data using apply function. And then logical operations, the equality, inequality, end condition, or condition, X or condition, and not. And also we learn how to condition the data. Often we wanna, for example, confine the data set into, for example, only the male individuals, female individuals, or the people whose height is more than 160 centimeter. So that kind of operations are often necessary for data analysis. So we discussed that. And also that we discuss missing values. That is also important because our database often have some missing data, and how to deal with it is important. And also we study the sum of the plots, the basic plots. So all materials are very practical and useful in real data analysis. Okay, so I will share the screen, and if we have time, we do some exercises today. So I try to do some exercise every time, or at least once every week. Okay, so yeah. So we continue from this page. So sometimes, we want to edit data on screen. So suppose that we have the data set. For example, we have okay, so suppose we have some vector x. Maybe vector x is the name of the vector. And y have some numeric vector. And we declare data frame, for example, as D. And D is this one. But for example, we want to change this 300 into 400. Then if we type the D arrow edit D, actually we can edit data on screen I don't know, maybe the letter is small, but you can edit this cell, for example, like this. Then if we close it and we type D, and D has been changed. So we can edit data as if it's just a spreadsheet software. And usually I don't recommend it because this record does not, so this, the edition. So this edit is not recorded in R, so we cannot really see what we did. So if we made this by error, we cannot really find it later. So usually I recommend to write everything in R code, but this functionality is available. Okay, so now apply function. So suppose that we have a data frame, yeah, like this. Sorry. Suppose we have 3 vectors, and we define a data frame, and it is here. And sometimes, for example, we want to take the summation of each row. So 7 plus 7 plus 12 is 26. The 10 plus 8 plus 8 is 26 as well, and so on. So in this case, if we want to get a kind of partial sum for each row, that we can use apply function. So apply D1. 1 means the row, first index of this data frame. So first index is row, second index is column. So D1 sum, then you can get 26, 26, 26, 26. So this may not be an ideal example. So all rows have the sum equal to 26, but you can get these 4 numbers at the same time. So yeah, this is the sum of each row. This is sum for each column. You can see 7 plus 10 plus 8 plus 9 is 34. And 12 plus 8 plus 9 plus 7, that is 36. So you can see the sum, the partial sum for each column by this. So this apply function is extremely useful because, apply function has another function as an input. So for example, you can take average instead of sum in this way, or even standard deviation, or some other functions. So it can be used in many occasions. Yeah. So this is extremely useful. And we have several functions similar to apply. We discuss lapply, sapply, and the tapply function. So suppose that we have another data set, but this time the data set is a list. Okay, so suppose that we define the 3 vectors with different lengths, and that we make a list of these 3 vectors. So this object L1. Oh.
Professor, I have a question.
Sure.
When you were doing the rows and the columns to find out the values, you put a 1, and then there was the rows, and then you put a 2, and then you get columns. Is it always like that?
Yes, always. Yes. 1 is rows and 2 is columns. Yep.
Okay, thank you.
Yeah. And so the list L1 includes 3 vectors. Actually, the 3 vectors have different lengths. So just it shows in this way. So sometimes we want to take for example, average of each vector. So first one, only 1 observation. So average is 2.5. Second one, the total is 2.4. So the average is 0.6. The third one, average is 0.3. Sometimes we want to calculate that. And in such a case, we cannot use apply function. Apply function can be applied for the matrix, maybe arrays, and also data frame, but not the general list. So in such a case, we can use either S apply function or L apply function. So S apply function applies this function mean for each object within L1, and the output is a vector. So for example, if you name this as capital S, then the first element is 2.5, second element is 2.625, and so on. It looks strange. This is summation. Why we have 2.625? It sounds strange. EF2 oh, sorry, this is 9.0. Sorry, 9.0. So 1.5 plus 9.0 is the 10.5 divided by 4. So that is 2.625. Yeah. So this is the mean, sample mean of these 4 observations. I thought this is 0.9. Yeah. And also another function, this is very similar, L apply function. Basically, you got the same answer, but here, the L apply, the output is a list of 3 objects. So object E, object F, and object G. So which have the same name as the original list. And each object have just one number, that is the mean. So this function is maybe more consistent with the shape of the data. So original L1 is a list. So L apply, the the output is a list. So that we have one-to-one correspondence. So this, for example, F is the second object in L1, and this F is second object of L apply L1 mean. So S apply and L apply basically calculate the same quantity, but the output format is slightly different. And the note that this is applied for a list. So we don't have any index here. So always these functions are applied for the list. So each object within the list. So we don't have to specify 1 or 2. Always just the object, the list, and the function. Yeah, and any questions so far? And next one is T apply function. This may be a little more useful than S apply and the L apply. So sometimes that we have a vector, maybe 2 vectors, gender and blood pressure. So gender is this, and the blood pressure is this. And then we define the data frame. Yeah, so this data frame, and sometimes we want to calculate the mean for male and the mean for female. And this format is different from previous one. So in previous one, basically the 2 groups. So we have 2 objects within the list, but here we have only 1 data frame, but sometimes we want to calculate the mean by gender. So in this case, we can use the T apply function. So at first, yeah, maybe it's we have studied. Sorry, we haven't studied the attach function yet. So yeah, maybe okay. So maybe to avoid confusion, we just remove original vectors, these ones, and we only have D here, and then the T apply function. And if we specify the gender, the BP, so blood pressure, and we want to take the mean for each gender. So the $ gender. Then we specify mean. Then we can calculate the mean blood pressure for female. That is 111 plus 94 divided by 2. So that is 205 divided by 2. So 102.5. And for male, the sum of these numbers is what? The 250 to 337 divided by 3, so 112.3. So in this way, we can calculate the group mean. And also this function is general. So for example, we can calculate group standard deviation. So male, we have wider range for blood pressure for these three people. The female, only 2 observations, but both are close to the mean. So standard deviation is much larger for male. Yeah. So yeah, so my recommendation is at least memorize this apply function. And other functions, yeah, maybe you, it's good to remember some other functions are available. Then if you need, then you can refer these slides to see how to use it. Any questions? Okay, so next one, the logical operations. So suppose that x is 5, y is 6. With semicolon, you can put the multiple code in one line. And the x is 5 and y is 6. Okay. So at first, we can see if x is equal to 5 in R. So this means R, the judges whether x is equal to 5. And actually this is true, so it returns true. If x is equal to 7, it's not, so it returns false. And yeah, this can be done for a vector. So x and y, x is larger than 6, y is larger than 5. The first statement is true. So false, false, because x is 5. Second statement is true because the y is larger than 5. So you can get false and true. Yeah, so yeah. So this is how the this inequality and equality works as a condition. If we type x is equal to 5, basically we define x is equal to 5. But if x double equal 5, the judges whether x is equal to 5. So it returns either true or false. X value is still 6, still 5. Sorry, we input this one, but still x is 5. Yeah, also that we can see if the x is not equal to something. So x is not equal to 5, then you can type x exclamation equals 4. And also the inequality, is equal. So the x is larger or equal to 4 or not. So that is true because x is 5. X is smaller than or equal to 4. Yeah, we can get false. So I think that this is basically everything we need. So x equals to 5 or not equal to 5, the larger or smaller, or larger than or equal to, or smaller than equal to. So we can do this. Yeah, for example, it can be used, for example, to count the number of, the number of observations which is larger than some value. For example, how many observations in X is larger than 55? So we have 55. So the X is a sequence from 1 to 100. So the 56 to 100 are larger than 55. So we have 45 observations. So it should return 45. So it has many applications. Any questions so far? Yeah, so next one is the AND condition, or condition, X or condition, not condition. So and or, probably you know that. And the basically, you know, that we have 4 patterns, right? So the A and B, we have the statement A and statement B. And if both are true, then of course A and B is true. But the A and B is true only if both of A and B are true. Right? And or condition, either A or B is true, then A or B is true. And X or condition, that is exactly one of A and B is true, then X or is true. So not is just not. So true becomes false, false becomes true. So okay, so again, the X is the X is 5 again, and Y is 6. And we can see if X is equal to 5 and Y is equal to 6, then this returns the truth because X is equal to 5 and Y is equal to 6. But if we ask R, X is equal to 4 and Y is equal to 6, it returns false because this statement is false. That makes entire statement false. And X is equal to 4 or Y is equal to 6. So X is equal to 4 or Y is equal to 6. So this is true because the one of the condition is true. So the X, so this X equal to 4 or Y is equal to 6, this is true. Even both are true, that returns true. And X or condition, the X is equal to 5, Y is equal to 6, then this returns false because both conditions are true. So if only one of the condition is true, this returns true. So for example, this. So this is X or condition. Exactly one of these 2 conditions are true. Maybe you can put the 3 conditions. Maybe the Z is equal to, for example, 9. Then, Z is equal to 9. And X or X is equal to 5. Y is equal to 7. Z is equal to 9. Sorry, we cannot. Actually, we have to use the X or twice or something. So it takes only 2 inputs. And not condition. So not X is equal to 5. This is false because X is equal to 5 is true. It can be used for just usual arguments such as Y is equal to 0. That is false. So not Y is equal to 0 is true. Yep. And double AND and double OR behave similarly to AND and OR respectively, but only AND OR, single ones, can apply for vectors. So that means, for example, X is a sequence of 1 to 10, Y is sequence of the maybe 5 to 14, and we can say that we can write an argument such as X is larger than 7 and Y is larger than 7. Then only this one, we have 10 observations. Yeah, so maybe this is, maybe Y is less than, for example, maybe X is larger than 4, Y is less than 11 or something. Then only this one and this one is true because X and Y here. So X is more than 4, that is 5, 6, 7, 8, 9, 10, and Y is less than 11, that is this 5, 6, 7, 8, 9, 10. So only these 2 observations satisfy both conditions. So we can get these true. And this cannot be applied cannot be done with double AND. If it's single, that's fine. For example, A is equal to 5 and B is equal to 10. A is equal to 5 and for example, the B is equal to 9. So double AND, it works here. And the double AND and the single AND have some difference in computational algorithm. I think the double AND, basically they judge the first argument. Then if this is false, then single AND. So double AND, the judges both arguments, but the single AND only judges the only first argument is false. So sorry, so to make it simple, we have two conditions, right? So two conditions, say A and B, and if first condition is false, we don't have to judge the second condition because anyway the answer is false. So in such a case, some algorithm that returns false, but some algorithm returns false. But sometimes the sum function, I think the double AND function, judge the both conditions anyway. So if second condition have some errors, then sometimes it returns the NA or some errors. So that is the logical difference between single AND and double AND. But probably you are I think that you don't really have to distinguish these two for this course. So just you can use always the single AND. So then that is more convenient because it can be applied for both scalar and vector. Any questions? Yeah, so just stick with the single AND and the single OR. Maybe XOR not. These are also useful. Yeah, and and using this condition, you can confine the data set. For example, we want to get the male data set from this D. Then you can get the D and only male. So gender is equal to male. Probably, maybe we check the structure first. This is factor, okay, so D gender equal male. Probably we need the D dollar sign. Then D dollar sign gender equals male object male not found.
Maybe put M in quotation marks.
Quotation, maybe we get, yeah, maybe that's true. Yeah. So quotation. So we get quotation. Then we get the set of males. Another code is subset function. Subset D gender is equal to male. Maybe again this one. Then also we can get the same thing. And if we don't use D, probably we cannot. Yes, so we have to specify the dollar sign gender. Subset function, only we have to write the gender. Yeah, so this is extremely the useful application of logical operations. Any questions? So it can be done also for numeric vector, for example, the blood pressure of more than 100. Then you get the data from BP more than 100. You can use multiple conditions, the male and blood pressure more than 100, then also you can get this. Yeah, so next, the missing value. So suppose we have a vector with 5 elements, the 70, 80, maybe 55, NA, and 99. Okay. And so weight is this vector. And one difficulty we encounter is when we apply some function on weight, often we get NA. So we have 5 observations, and the 4th observation is unknown. So we cannot calculate the mean. So that is what R says. But usually we want to calculate the average weight, except for missing values, excluding missing values. So how to do that? Some functions have functionality to remove NAs, that is NA.rm option. So mean weight, NA.rm option is equal to true. So mean, ignoring, excluding NAs, that is 76. You can see the average of these 4 numbers is 76. But some complicated functions don't have this NA.rm option. Or maybe you develop a function and you ignore this feature. So NA.rm cannot be used. So in such a case, we want to see if each observation is NA or not. And the one complicated fact is that if you use this logical operation, whether or not weight is equal to NA, we want to have the vector of true, the false, 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 true, false. But actually this returns NA, 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 because this means we are unknown. So this number is unknown. So we don't know the condition. So we cannot judge whether the 70 is larger than NA. So that is R says. So actually the logical operation of equal does not work for NA. So we need a special function to see each observation is whether NA or not. So that is is.NA function. Then we get the false, 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 true, false. So basically with this is.NA function, we can identify which observations are not missing, which observations are missing, or which observations are not missing. So if you want to exclude NA values from original vector, you can type not is.NA weight, then that is true, 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 false, true. So the weight of this function, this vector, the picks up only 1st, 2nd, 3rd, and 5th observation. So we get 70, 80, 55, and 99. So we can successfully remove NA. Then you can do whatever you want. You can take the mean or standard deviation or anything else. So we need is.NA function. Yep. So also we have to be careful that for example, the dgender, dgender is MF, M. Okay, so suppose that we have a vector which includes some NA value, for example, MF, NA, FM. Then if we see if gender is equal to M, so it returns true, false, NA, false, true. So this NA is not M, but since it's unknown, the R only returns NA. So sometimes we expect this code returns the true, false, 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 true, but actually it returns the true, false, NA, false, true. So we have to be very careful to deal with NAs. Any questions? Okay, so next we go to plot function. So plot. Suppose we have two vectors, maybe x is 1 to 7. Okay, so y is equal to x squared. Y is this. 1, 4, 9, 16, 25, 36. Yeah. So in such a case, at first, what is the plot of x? The plot of x becomes this. Maybe this is not really the ideal example. So maybe we define x as 10 times x. Okay, so x is now 10, 20, 30, 40, 50, 60, 70, and the plot of x, then that returns this. So we have 7 observations. So x-axis is index 1, 2, 3, 4, 5, 7, 6. Then x value is 10, 20, 30, 40, 50, 60, 70. So we have this plot. So the default is scatter plot, but since we only have one variable, the horizontal axis is index. Plot x and y, then it returns this. So x values are 10, 20, 30, 40, 50, 60, 70. And the y value is 0, 10, 20, 30, 40, 50. So we have this. If we want to make the line graph, the type is equal to L. This is a line graph. And the type, I think the type P is the same as original one. Type B is this one. So both the scatter plot and lines. So sometimes we have, so in this case, it's good because the x is ordered by increasing order. The observations are ordered in increasing order, but sometimes it's not. So for example, suppose data frame E is x and y. Okay, so remove x and y. Okay, then we have different order. For example, we change the order into just random order. So E is this. So X has observation, the same observations, but they're in a different order. So in this case, for example, plot the E $X, E $Y. And this is just the same scatter plot, but if we make it as a line plot, we have some trouble like this, because just this, the R uses this order, 70. We start with 70 and next 10 here, and next X is 40. So this, so we cannot really see the original, the line graph. To make original line graph, you have to order the observation in E by increasing order. You can use order function to make it. I don't discuss it here because it's too complicated, but we may have this in exercise maybe. Yeah. Yeah, actually this can be done by E by increasing order of X. No, increasing order of E, sorry, EX. Yeah. Yeah, so this is the basic plot, scatter plot, line plot you can make with this plot function. And also we often use histogram. For example, that we make the 100 random numbers and we name it as maybe R. So R is 100 random numbers with the standard normal distribution. And we want to make a histogram of R, then we can make this histogram. So bell-shaped curve. Only 100 observations, so it's not really exactly bell-shaped, but that is. We can put some options, for example, breakpoints from maybe negative 2.5 to 2.5, then maybe negative 25 to 25, then maybe multiply by this. Then the breakpoints have the increment of 0.1, okay, from negative 2.5 to 2.5. Maybe we have not too many observations, so this isn't really the bell-shaped curve, but yeah, but you can still see some indication of bell-shaped curve. Maybe if R is more, R have more observations, maybe 1,000 observations, then maybe it looks better. Yeah, and it returns an error. Do you know why it returns an error? Just when we increase the sample size. Anyone has any idea on why this returns an error?
Maybe some of them are outside of the range.
Yeah, that's true. So the range of R is the negative 2.9 to 3.57. So actually this does not work. So we need to modify code in some way. So in this case, maybe the maximum is 3.57. So maybe if we make it 36 to 36, then we can make a graph. So sometimes this kind of error appears. Yep. And we have the many other options. The help, if you type help of plot at first, then yeah, we have the two packages using this default scatter plot function. Yep. You can see several options. The type L is line graph, but the B is both, but also we have some others. The C for empty points joined by lines. And the O for overplot points and lines, overplotted points and lines. And the S is the step functions, and H is histogram-like vertical lines. I don't know. I haven't used this H, but also you can specify the range for X and range for Y by specifying X limit and Y limit. So this may be extremely useful to overlay the two plots with the same axis. And yeah, many other options. You can change the label for X axis, Y axis, and yeah, you can change some axis annotations and yes, many others. Yeah, you can try these. And you can also change color, background color, the point character, for example. Plot is this, but you can change, for example, point character PCH as if you want to make everything cars, then actually only first letter is used, but the KKKK. So this is possible.
Professor?
Yeah.
So actually, sorry, going back to the data frame, what's the reason again that you use the remove function when you're creating the data frame? I think you did it a bit earlier.
Remove function?
Yeah, like you I think if you did it a bit earlier when you were creating the data frame, when you were plotting E and Y, and then you said RM something.
Oh, I see. So that is, we created X and we created Y, then we created E, which includes X and Y. So then X is duplicated. So to avoid confusion that we delete the first two.
Okay, I understand.
Yeah. Yeah, and the help of parameter, the R has several parameters. For example, the margin for each direction or some other parameters. So the to change parameters that you can use the parameter option. Yeah, so you can search for this to change some graphics of the parameters. for example, CEX, maybe CEX can be used to change the size of the plot. CX4, then 4 times larger. So the graph consists of large case. Color, yeah, we can change it. Yeah, sometimes the people use the color, like one to 7. Yeah, we can change this. Yeah, so that is for chapter 1, and here we go to chapter 2. We still have a lot of time, so we go to chapter 2. Do you have any questions on chapter 1? Okay, so we go to chapter 2. Maybe we have to use slides because it has more explanation than chapter 1.
You're muted, Professor.
Know why? Oh, sorry, maybe I pushed. Sorry. Yeah. So chapter 2 discusses our environment. So how to read data, how to export data, how to the import the source code or export output and so on. So at first, before using a project, I recommend to type the get working directly. So then you get the working directly in R. So get working directly, then we get this, the working directly. Then you can set your own working directly. Actually, you don't really have to type get working directly, but usually you are confused how to write the path to the the working directly. So in my computer, that starts with /users/ and my name. But maybe in some computer, maybe the C :/users /something. So my recommendation is to type get working directly first, then the set working directly into your computer. Then all input and output files that, come from and go to this directly. So you only have to specify the file name if you specify working directly. Terminating R, usually people don't care, but if you type the Q parenthesis or quit parenthesis, then there are automatically quits the Q parenthesis. Yeah, so don't save. Yep. Yep. And session management, the ls parenthesis shows all objects you have created. I don't know. I have already created in some object. Yeah, actually in default our working space that I defined several objects F and G and so on. So if you wanna delete this delete these functions, then you can remove, for example, F and maybe remove G, LM2, X and Y, then only these objects remain in my R workspace. Yeah, so remove A, that removes object A. Sorry, this should be the the pound key, not %, %. And ls, yeah. And if you want to remove all objects, then you can type the remove list is equal to ls. So basically, we specify the everything to remove. So once you do this, then we don't have anything. The character 0 means nothing, so empty set. Yeah, so you create some vectors, then ls, that you get x and y. Yeah, and if you do some project and you want to save this in a workspace, then you can save workspace. So maybe in Mac that we have on the top row that we have the workspace. And if you choose this workspace and save workspace file, then you can specify the place you save the workplace. For example, you can save workplace in directly in chapter 2. So chapter 2, then you can name it. So workspace 1 or something like that. Then you can open this workspace. I think this is yeah. Yeah, workspace 1 here. I have to close this workspace first, but I close. And also, I think that this need extension. I think this is all data. Maybe. Then, okay, so we load the workspace. So if you type X, we can see what you have created. So if you have to shut down your computer, that you can save workspace, then the next day you can save workspace. But the important thing is the object remains, but the code you wrote does not remain. So we don't see how to create, how we created X. I typed X, arrow 1 to 5 to create this X, but that information, that code does not remain. So only objects remain in a workspace. Yeah, so that is this, yes. So with GUI, you can go to workspace and save workspace, or in Windows, file and save workspace. And by script, that you can type in our console the save.image, then the file name. And it does not save the scripts you entered, so you can use other methods to save this. And the load workspace, the same thing. So if you type the load data, so this can be used. In some very complicated project, sometimes you have to quit the R session and have to load another workspace. So this can be used in such projects. And actually, before we have the save history function to save your code, but actually this function does not work anymore. So I don't know, maybe some people created other packages to save your history, but usually they just, my recommendation is to save file in a different place. If you use RStudio, usually you save it as a R Markdown file. And if you don't use RStudio, then probably you use just text editor to put your to save your code. And another thing is the output some file. output some file. So in R, if you type this and the object A is saved, and sometimes we want to see the result of the A square, but not on screen, but in a different file. Especially if the size of the output is large, you don't want to see hundreds of lines in R. So in such a case, you can specify the file name to output the contents. So that can be done by sync function. So after this sync function, you type A square, then nothing appears on screen, but the output is saved to this text file. And if you want to get the original state, so that you want to get the results on screen again, then you can type the sync, the parenthesis nothing. Then the output will be on screen. So if you type this, then this appears. Yeah, that's it. And sometimes you want to save output after the existing file. So in such a case, that you can type append is equal to true, then the new results are written after the previous, the contents in this output 01.txt file. If you just type this, then it overrides the result. Any questions? Oh, already 27. Do you want exercise or want me to continue?
Continue.
Sorry?
I said continue.
Okay. Okay, so maybe some exercise, maybe? The exercise 2 is available on the website. So maybe we can do the first question in exercise 2. Maybe I will show you. Yeah. So I think that you can do this with the knowledge from the previous lecture, but we want to, okay, so we have a function f of x cubed minus 5 times x squared plus 3 times x. So we want to check the value of these functions for these different values. So from negative 1.00 to 5.00. So we have 601 values. And we want to create a vector of the f of these numbers. And we can do this just by using vector. You don't really have to create a function, but if vector x have 3 elements, you can calculate the value of this function at the same time, at once for all observations. Then you can make a graph, for example, and also you can see where is the root and so on. So we would like to do this one. So maybe I would like to stop sharing and make breakout room for discussion. So I recommend one of you share the screen and discuss. Maybe how many students? Maybe 20, a little more than 20. Maybe this time we try 5 breakout rooms. Okay, so for 10 minutes. Okay, so I assume that everyone is here. So question. Yeah, I think the some groups are successful to get the final answer. So question 1, okay, so problem 1, question A. At first, we have to make a sequence from -1 to 5 with increment of 0.01. So there are several ways that maybe I would do 0.01 times the sequence of -100 to 500. So this is, okay, so this makes sequence of -100 to 500, then we multiply by 0.01. So this becomes -1 to +5. Maybe it's the first few observations by head of X. So you can see this. Maybe another way is X as maybe sequence from -5 to 1 and the by 0.01. So this also returns the same thing. And question B,
It's not the
have to-
same. It's not the same.
oh, sorry. The -1 to 5. So yeah, -1 to 5, just the mistype. Yeah. Thank you. Yeah, -1 to 5. Yeah. And the B, and we have to calculate the X to the third power and -5 times X square plus 3 times X. Note that every time you need asterisk to represent, to express the multiplication. And we define this as Y. Then, you know, these are first 6 result of this. So for -1, the Y value is this, and the -0.99 Y value is this, and so on. And the question C, that we can plot X and Y. Note that X is already in increasing order, so you can just use plot XY and the type is equal to L, then you can make the scatter plot. Yeah. This is line graph. That you can use this as the usual, the scatter plot, but also maybe you can specify B for both. And you can see about maybe 4 point something, maybe 4.2, 4.3. You get the largest root. Then you can actually make x-axis by using AB line 0, 0. So this is the y is equal to 0 plus 0 x. Okay. So you can type, for example, AB line 1, 2 to draw y is equal to 1 plus 2x. And 0, 0, that becomes y-axis. So you can put it as, sorry, you can put the x-axis. So we have 3 roots, but the largest one is about 4.2 or 3. So you can see. So we want to find this, and no mathematical solutions because anyway, we have 3 solutions here. So maybe a strategy is maybe to confine the range. Maybe we want to find a point which is closest to 0, whose y value is closest to 0, and x value is between 4 and 5. So maybe the y value. So this is, okay, so we have 601 observations, right? length of y is 601. So if we type 501 to 601, so this is basically f of 4.00 to 5.00. Sorry. Yeah. So yeah. And we want to find the closest, the smallest one. So that is, yeah, you can find it directly from here. So this is closest to 1. So this is 31st observation. So actually the 4.30 is closest to the largest root. Maybe you can make some trick to identify this without seeing these numbers, maybe absolute value of these numbers. And we can choose the smallest one. Actually, we have the which mean function to find this. Then this is the 31st observation in this vector. So this makes the value smallest. So that means 31st observation is f of 4.30. So 4.30x is the closest to the largest root. Yeah, so that's the answer. Yeah, so that's it for today. And yeah, if you don't have any questions, to see you next week.
Thank you.
Thank you.
Have a good day.
Have a
You
nice
too.
day.
You too.
Okay, see you.